I'm going to show you some of our recent results from the RiLakS project. That work was done with my RiLakS mates, Alexis Nutz and Thea Aragon. And on this first slide, you can see a very nice picture that is for me an epitome of the Turkana Basin. So in the first foreground, you can see the Lapur sandstone, which is sandstone that have been deposited in the Cenozoic African rift systems. They continue back in the picture where you see LS over there, and they are lying on the Precambrian basement that you can see in the background, and they are topped here by the Turkana volcanics. And if you go to the right, then you can see the Murarit Lapur fault, which is the main border fault of the basin, and it separates the Lapur sandstone from the Plioquaternary, Nachukwi, Kibish, and Galanaboy formation. And these are the deposits that are related to the East African rift system. And if you have very good eyes in the background, you can see the Omo River Delta here, bringing sediments and water in the Lake Turkana. So that's a nice view of the basin and gives you a nice abstract or summary of the basin. So Turkana Depression, where is it? You see it very well on this very nice picture from Raphael Peak. It's a low topography area in between the East African plateau and the Ethiopian plateau. So in between the Kenya Rift and the main Ethiopian Rift. And it's world famous because for human origins, you have a lot of hominin remains there, also stone tools. That's very interesting. It's a place where you have a lot of oil exploration very recently by Tullow Oil, Africa Oil, and other companies. And it has been, for us geologists, it's interesting because it has been used as a modern analog for Rift Lake Basin, for example, with the Project Probe in the 1980s. So in the Turkana Depression, you have a very good time scale that has been established because you need to have a good time scale to study biological and especially human evolution. So this time scale is based on volcanic ash beds that you can see here on the screen. And this allowed several authors to establish this very highly resolved chronostratigraphy. And it's very interesting because there are tens of volcanic ash beds there. So you have a very good chronostratigraphy and you can do some basin scale correlation. So for us, it's the ideal context to focus on sedimentary facies in a scene rift sequence. So the RiLakS project for Rift Lake Sedimentology was a collaborative research project funded by Total. The idea was to do some sedimentary facies analysis, mainly in the field. Basically, we used the hammer and the notebook, and we produced 1 kilometer of highly detailed logs. The coating can be seen on this screen. Alexis Nutz, at that time, he was postdoc in Strasbourg. Thea Aragon, she was a master student at that time in Strasbourg. And of course, Francis Emokwi Ikai is our local guide. And the idea was to address 3 fundamental questions for continental rifts. So the first one was, what's the geological record of the early rifting stage? Then, what is the sedimentary record of scene rift? Having in background or in mind that we have to distinguish tectonic from climate forcing. And the last one was, which sedimentary process control the distribution of clastics and bioclastics in a rift lake? And the idea behind was to go farther than the classical river delta turbidite model. So before I begin, I just explain you my background of how a sag basin geologist moved to a rift basin. So I started to work in the Lake Chad Basin, and so I was interested in stratigraphy and paleo environments of early hominins, the story of Paleo Sahara and megalakes. And in the meantime, in Turkana, there was a major archaeological discovery by a French team led by Hélène Roche. But then there was a stratigraphic controversy on this discovery. And at the end, my friend Jean-Jacques Tiercelin and I, we were asked to look at this problem, and we found a happy end to this controversy. So let's go to the results of the RiLakS project. And we start with the early rifting question. So that's the study area, the Lake Turkana Basin that you can see here. The study area is just here, but on this picture, it's very interesting because you see two cross sections that show you the structure of the basin. So North Lake Basin is a single rift half graben system, whereas to the south you have a series of different half graben. So when we went there, it was a bit difficult because it's not an area where you have sediments from the early rifting. If you look at the geological map or other papers published, it's only dominated by volcanics. But what was interesting is that there is a nice system of folds. So we went there, and of course we found the Turkana volcanics, as you can see here. We found the folds, and in between, inside of these folds and of this basin, we found sediments. You have an example here with fine-grained sediments, fine turbidites, or here you have coarse conglomerates with impressive facets. So it shows that there is a sedimentary infill in this area. So we were able to produce a geological map that you can see here. And of course, we produced a log to record this formation and several cross sections. And so what's the conclusion? The main thing that you have to remember about this paper is that the Ekitale Basin is a micro basin that records the first pulse of the rifting in the northern Turkana Basin depression. So you can see this Ekitale Basin, small basin here at the beginning of the story, and the remain of this Ekitale Basin nowadays. If you want to see the detailed reconstruction from the local system and the regional scenario, please look at the paper of Thea Aragon. Then the second point, which is always exciting in the Rift Basin and in any basin, is to decipher between climate and tectonic. So we have three papers where we are able to identify climate forcing. One is sub-Milankovitch cyclicities. Another one is a paper when we see that Milankovitch cyclicities controls transgression and regression sequences. But I will only talk about this one, the most recent one, which is the masterpiece of Alexei Nutz. And so it's a long-term record from 4 million years to 0.77 million years. And we were able to differentiate tectonic from climate, not only regional climate, but climate, local climate versus regional climate. Once again, location map. We were working on the Nachukiwi formation that you can see here. If you look at this map, then you can see some dots with numbers. These are all the sections that we have documented. This is how we did basic sedimentary facies analysis, alluvial fan, microbialites, offshore muds, and we were very excited also by the shore face deposits. So at the end, we produced a lot of logs with interpretations in terms of sequence stratigraphy. When you put everything together, you have this nice summary with the time line here. This is the Murarit fault, and you can see the rift age facies. And what is really interesting here is that we were able to distinguish two types of rift edge facies. The first one is the supply-dominated system, which is river-dominated sedimentation, and there's an accommodation-dominated system where wave dominates the sedimentation. Thanks to this, the second outcome of this paper is that you can reconstruct the success paleo landscapes from the Turkana Depression from 4 million to 1 million years ago. And you can see it here, nice pictures, nice reconstructions, where now people interested in human evolution can replace fossils and their discoveries in very nice reconstructions.
Mathieu,
So
you are 10 minutes now.
Yeah. Sorry?
You are 10 minutes now.
Okay, I'm close to the end. The last outcome that I will not develop here is that we were able to demonstrate the importance of wind-induced hydrodynamics in the record and in the sedimentary record of this of the Lake Turkana and Paleo Lake Turkana. So basically, Lake Turkana is what we consider as a wind-driven water body. So what are we doing now? RiLakS is not relaxing. We have an ongoing project which is focused on Plio-Pleistocene hydrosystems, and we compare the freshwater mollusk assemblages to the sedimentology. We have another project which is Lakes 3D, simulating hydrosedimentary processes and products in lakes using Delft 3D. So it's a partnership with Delft University and Deltares. And of course, we are looking for subsurface data from oil exploration. So if you have cores, well logging, onshore, offshore seismic profiles, let us know. Last slide. For me, the greatest challenge today about human origin is linked to the fact that we have hominids in the East African rift system, and there have been also hominid discovered in Chad Basin in the Sahara. So the question is, how can we explain this space and time distribution of hominids? And I think there's something happening in between those two areas, and we should work on having some synthesis of rift of basin evolution in these two areas. So easy to do sedimentary basin synthesis, and of course we must go to the field. So that's all for me. I would like to thank you for listening. If you need any of those papers, just ask us and we will send them to you. Thanks.
Thank you, Mathieu. That was a great overview. We have time for a few questions. Just type them in the chat or queue if you have one. I have a question to kick things off. Oh no, Annette, you go.
I'm sorry, I have to ask the question again that I've asked Veronica also, Mathieu. You showed on one of your last slides from your 2020 paper a timeline, and yes, this one, I think.
Yeah.
And you see that this is evenly spaced, your on the y-axis, but then you come to 1 million years, and then there's a big gap to 750,000. And this is exactly what we have in the Soguta Valley. So I was hoping that when I saw your title or your presentation, that there's more information from the Middle Pleistocene. But what's going on? We have here also red, which is a small lake, actually, right? Or even no deposition at all. Is that correct?
Well, there is lake beds, but the how we say that it's more a progradation of the course of the alluvial fan system. But then we have no more deposits here, and we have the Kibish formation, and we didn't look at the Kibish formation.
Do you have an explanation why you have the erosional gap there? Is that tectonic related, or what is your idea about it?
Well, then you have in this basin the border fault that was first active is this one, is the Murarit Lapo fault, and then the shore fault developed and start to be the most active one. So yeah, I think you should look in the lake basin for that. No more in this area.
Okay. Thanks.
That's my guess.
let's try.
Yeah.
Josephine, you also have a question, and that will be the last one for today.
On my camera and microphone. Thank you very much, Mathieu. I'm really intrigued by actually your last slide when you say that the biggest challenge now is to find out what was going on between the Turkana Basin and the Chad Basin, and I very much agree. Of course, we know that there's this old, much older rift system going largely east-west. But that it's still a low-lying area nowadays. So are you seriously suggesting that would you like to develop a project there, or how would you see that challenge?
Yeah, well, I would be very happy to have a project doing that, exploring that. It's for me, it's a very exciting challenge. But I don't have the money for the moment, if that is the question. But
no, I think if you have a good idea, the money will follow. So
yeah, maybe not always, but yeah, of course there are many questions, and of course the fact that I say that it's the greatest challenge is of course from my point of view, and my point of view is the point of view of someone from the Chad Basin moving to the Rift Basin. And the discoveries that have been made in Chad Basin, they are now, yeah, it's been 20 years, and from the moment nobody addressed this kind of question. How can we explain this?
mm-hmm.
And it should be interesting to look at that.
Yeah, I very much agree that we should look into it. And I think Jean Renaud also has a lot of indications that are actually very important connections between the East and the West. Yeah, so.
Yeah, I think it's an idea that I'm sharing with all my my Chadian friends. So it's not only my idea.
No, it's no, but something to follow up on, definitely.
Yeah. Yeah, right.
Good luck with that idea.
Yeah,
we have to stop at this point.